That seems to be working.
Very good, very good. So
All right.
I don't see any of you, which is always confusing because I do a lot of presentations on big conferences and stuff, and I can actually look at people and I enjoy seeing you and interacting with you. But now I'm sitting here behind my laptop in the Netherlands, and it's nice weather outside as well. So so I'm just thinking of you sitting in front of me, looking at me, right? So please stay with me because I have a very fast overview session for today because I would really talk about how to innovate and thrive with cloud. And although you can't see me, if you would be in AI, you would look at me. You would probably look at me like this, right? Well, I don't know about your attractiveness scores. That's what they come up with, right? But you see a lot of things. I seem to be happy. I seem to be male and so on. I think that's one of the wonders of technology in this time. When I talk about thriving with cloud, actually, I'm not just talking about the technology side here. I would like to talk about how can also make cloud the world a better place. Yeah. So, and before we go into all of that, and I will also go to a bit more technical details, I would like to always take a step back and say, where are we actually in time? And where we are now is I think we are very much in what we call the smart machine age. And if you look back in time, we didn't have anything like IT, right? We had things like information, agriculture, handcraftship, and so on in Industry 1.0. Then we moved to new things like machines, to knowledge, low-cost paper, and also knowledge became very important. Yeah, a very important time, I think, in history of mankind. And we called that also the machine age. And where we are now is some call this the second machine age. I always call it the smart machine age. And actually, what you see now is that everything is becoming smart. Smart machines, smart robots, smart organizations. And if you look at the purpose, you really see that the purpose of organization is also changing because you really need to have an overall purpose. To also to be a better company, right, and to contribute to the world as well. But also, what you need to be is becoming more agile in the way you operate. And it's not about paper anymore. It's not about IT systems in that sense anymore. It's all about digital data and how do you use digital data. And I just listened to this the presentation of Steve before me from Google. I think he has some interesting insight also how Google is positioned in supporting all of this. Of course, I will come to that in the end as well. But the third element of this is intelligence, because if you want to be smart, of course, you need to be intelligent, but also you need intelligence to be smart. Yeah, so how can you make a smart machine? By being intelligent. How can you make a smart organization? By being intelligent. And I thought about this a bit, and I thought actually this is also a concept that is, I think, pretty known for the last couple of years. But this actually, what is a smart company? Yeah. So I think you probably all want to build smart companies. But what are smart companies? Well, smart companies, they have a high capacity to adapt to change. Yeah. So they're agile, they can change. And they use smart technology, things like AI, right? Digital data, human factor, and of course the data itself to respond to the customer market and to the environment. But they do this in a sustainable way. And there are three important topics, and I would like to tip on them very shortly in the presentation also today. So you get a bit of a clue of it, but of course the time is limited, so we can just go through that a bit. But I see three important parts that are coming together also that can help you to make a smart company. The first one is everything around cloud, right? But it's not just about cloud, it's also other computational power and so on. I will come to that, like supercomputers and quantum and so on. But we also see this concept of what we call hybrid IT. Yeah. So hybrid IT is a sort of the combination between public cloud, but also on-premise systems and also on-premise cloud. And that together can bring you, well, not just a cloud, but a landscape with digital capabilities. And I think that's really the essence of where we are talking about when we're talking about cloud. The second part, and this is really about the evolvement of agile. Yeah? So we have these old waterfall models and so on, and I will not talk about agile that much in detail, but you really see a couple of things coming together. Yeah, biz DevOps, BizSec DevOps, but now also FinOps, where the financial aspect is also coming in this. So it's already a combination of BizSec Dev FinOps. I think it's a perfect word for any game, Scrabble game you're always playing, but probably the word is not in there yet. So maybe in a couple of years. The third element is very much about the data capabilities, yeah, because it's okay that you have data, but can you actually access that data? Yeah, so can you actually access that data as digital data? Do you know what it is about? But also, do you have the intelligence and the methodologies and so on to get intelligence out of this? Yeah, so you know what you can do with it. Let's start with what makes you a smart organization. Well, a smart organization, in my view, really starts with a purpose first. Yeah. So I don't know if you guys are familiar with sustainable development goals, but I think that's really the thing that is going on now in the corporate world. It's important for every company to have a purpose and also around sustainability. And the SDGs, they really give you a good idea of where we want to go to. And these are goals that are set by the United Nations, sustainability goals. And every country, but also organization, try to actually define a couple of them which are important for them. And also they try to improve these. Yeah. So at the end, that means as a company, you deliver social value. Yeah. So besides the customer value, you also create social value. And I think if you look at use cases that we actually have now with this digital data and so on, you will see that a lot of these kind of use cases are actually very much fitted for these kind of purpose kind of approaches. So when you look at the smart age and also the smart machine age in that sense, and we are talking about this purpose-driven organization, what enables it is really three core elements coming together. Data, digital, AI in existing maturity of AI. And the third power is really computer power in all sort of forms that are around there. And if you combine these three, you can actually make these smart computers, but also make these smart robots and also make these smart organizations. Yeah, an organization, for example, that can make decisions based on digital data and do it on an artificial intelligence kind of way. Yeah, that also supports the business and so on. So I would like to touch in this session, and it's a very short session, of course, to try to touch all of these very shortly. Okay, so hope you're all ready to go for it. Let's dive into it a bit deeper. And maybe just before we jump into that, I think a good example is what we see now also with Google, that also actually launched TensorFlow for quantum computers. Yeah, so they already had TensorFlow for AI, right, as an AI platform, as an AI technology, but now they are also looking at the combination of quantum computers and AI by deploying TensorFlow on quantum. And I think that's actually a very interesting combination. Of course, I would like to talk to you for hours about quantums and supercomputers and how this all comes together, but we do it in a quick way together. So first, when we talk about smart society, it's all about working together in different value chains. Yeah. So if you're in a bank, you need to work together with other companies, for example, in mobility, to actually being able to solve these sustainability goals. Yeah. So it's not just about you anymore. You really need to work together, need to transform the industry. So we always talk about data-driven digital arenas, actually, instead of separate companies. Well, the way to share information. A couple of years ago, this was not so normal. I think now it's very normal to share everything with data, digital data, through APIs. So companies can actually do transactions with each other, but also share their content with each other. Underneath all these industries and APIs and so on, there can be a landscape, a digital landscape, actually, that exists of business applications that are already out there, but also the new cloud native applications. And they all run on this hybrid digital business platform, yeah, where you have all these digital capabilities, either coming from your on-premise services, maybe your SaaS services, maybe even all traditional systems, but also the new Googles, yeah, the AI from Google, for example, but also the AI from AWS or any other hyperscaler. And of course, we have a couple of them by now. If you look at this hybrid IT world, it's not only about cloud, right? Where we often have to deal with is, well, this is that you have different layers, right? You can have an infrastructure layer, you can have the PaaS layer, the SaaS layer, you can have actually a variety of systems underneath. Yeah, you have maybe shared service centers, you have community clouds, for example, in health, you have your private on-premise, you have your public cloud. So actually, that's all underneath your hybrid IT platform, and you all need to manage that and make sure it runs smoothly, but also secure, and you get the best services out of every platform you're using. But you also have to deal with the old world and the new world at the same time. So on the old world, the more traditional world, you probably still have waterfall approaches, virtualization, bare metal, cost center approaches, and so on. And on the right side, you have this more modern, fast IT, where everything is around cloud native, pay-as-you-go models, anything as a service, and also your Scrum DevOps teams. And it's actually it's not so difficult to deploy a new application on a pure public cloud, right? But actually managing this entire overall status and also transforming from traditional to modern and keeping this in balance and secure, I think that's one of the biggest challenges of organizations the coming years. And we would call that hybrid IT. One of the elements is smart machines, and I already said that this is one of the 3 core elements. And of course, if you look at the history of AI, you already see that we got more mature over time, right? The Alan Turing test in 1915 and so on. And in 2018, actually, there was a language processing sort of challenge, and actually it outperformed some of the language processing capabilities of students at Stanford, I think, which is very impressive. And of course, there are many more examples than you see here, but I think this really shows that we are getting very much into the maturity of AI. When we talk about AI, though, we are not at the moment, that we all have in our dreams about this intelligent robot walking around where you can have conversations with everything, because in itself, AI exists of a lot of components. And I think that's actually how you need to look at it. These components on itself, they get more mature. Um, and you can actually use these components. So you don't have to wait till the end of the ride that everything is mature. But over time, these components get more mature. And there are a couple of them that are so mature already that you can start using them now. Yeah. So not tomorrow, not next year. You can start using them now. You can go online, public cloud, and so on, and you can start using them. And this is a good, I think, example of the type of components you actually see in AI, right? Image recognition, speech to text, text analysis, classification of data, but also predictions and so on. These are all elements of AI. And I think especially here on the left side, the text analysis and the speech to text and those kind of elements, they are very much available already on different platforms already, and you can already use those. And it's even or almost common already, right? And you can use all these components together to actually build new sort of use cases. And I just gave you a short list, but what you see, for example, here is just a short list of some of the Amazon AI services on the left, but also some of the Azure services, text to speech, speech to text. I didn't put any Alibaba and stuff in this one overview, but of course, if you also look at the other hyperscalers around the world, there are also other AI capabilities on there as well. So there's already a big list of services that you can actually start using right away. Machine learning on AWS, where you can start right away, but also the components on Azure in this case. The text to speech, I think, is a very good example. That brings me to the sort of overview. What can you actually do with AI? And you see a sort of moving city here with people traveling around the city. And you see that things are monitored, right? Buses, taxis, highways, railways. And so it's not so much only about the digital data, the flow of people and where they are, but you also see intelligence over this, right? What are the recommendations? Where should you put the security people? Yeah, where should you put the police if you know an event will end in a second? And what if you put an additional layer on top of it, for example, the weather? And how can you actually make predictions and so on in models like this? I think that's a very interesting challenges we'll have the coming years. The more layers, the more complex it gets, especially when you have combinatorial problems, right? Because it's not just AI on monitoring cars, but you actually have to connect different sort of intelligence and different sort of levels of information here. So what you can do already today is predict demand, analyze performances of problems, or discover insights of patterns, or detect incidents or opportunities, or find people or content. Yeah. By using analysis on video stream, you can actually detect cars, you can actually detect people where they are, but you can also detect crowds. You can also detect, for example, lost children in a busy environment. So these are very interesting use cases, and you see a couple of them here. For example, people that are suspicious walking around, what are they doing? Looking for people if you want to track and trace them, of course, maybe for an airport. Optimization of patrols, or maybe find objects which are laying around. Count people, they come into the shop, and follow their patterns and where they're going. Also figure out congestion and so on, especially also interesting in Corona times like this. But also find illegal parking. Are people parked somewhere and they didn't pay for it? I think that's also in itself a very interesting example, because that means you can also combine old technology and new. And so what you see here is just a standard camera, and the standard camera is watching a parking space, but you put a layer of AI on top of this, and then you know what are actually parking spaces. And you actually also know when a parking space is occupied or not. If you transform that into data, you can actually create also panels out of this, right? Smart parking panels. So you know exactly when something is full or not. You can even direct cars to the right spot. You can create it into the government app so you can actually know where you can navigate. Over time, you also will know which things were occupied and which are not. Yeah? So is it even useful to build additional parking spaces or not? Or you can even figure out what time of day these kind of things are actually used. Yeah, very interesting thoughts, I think, are very simple. Another way of looking at this is from the financial services world. Yeah, so if you look at the top 10 AI initiatives in top banks and insurance companies, you see actually that these kind of companies, they are already doing cases with AI, yeah, for their market. So what you see, and this just gives you a bit of a list, is they are trying to use AI to figure out anti-money laundering patterns, right? They're trying to use it to automate the trading. They're trying to see if they can use it to automate legal work or fraud detection or smart advisors or virtual customer interaction. Yeah, so these kind of components are built on these kind of AI components. And you see the same with the most actual list on insurers. Yeah, for example, connecting health apps to sensors, but also self-service chatbots and so on as well, but also a chatbot for claims. Because if you open the box and you look at these chatbots, you actually see that you have on the left hand here a banking customer or an insurance customer. That person actually talks to a microphone. That text is actually, voice is translated into text, it's recognized. Then it goes through an AI chatbot that reads the text, searches and so on, and gives an answer. Then the text is actually translated to speech again, and that's given back to the end customer in this case. And so that's how you use these different components to actually build a case through your mobile application to chat with, in this case, your customer. Like I said, we are going a bit fast today, so I'm hoping you're still on with me, because we're going down a bit more in one of the other technologies, and one of them is quantum computing. Sorry. Quantum computing, I think, is very, very interesting for us the coming years. This is one of the top technologies that might change the world. And of course, we don't have a clue about what will happen with quantum now. Yeah, because think of this as back in 1968, we invented some of the computers in the first supercomputer. We had no clue what we could do with it, right? We are in the same space now. So 2021 is actually now. So this year is actually sort of 1968 for quantum, which means we don't really know exactly what we can do with it, but there's enormous potential. Yeah, just to give you a very small idea, normal computers only calculate with zeros and ones, and supercomputers, they can actually calculate with 0, 1s, and every other number. Yeah, which means you only need a couple of bits, or in this case they call it qubits, to actually solve very complex problems, especially the type of problems that you have seen before. For example, when you look at the city and you actually also have to deal with people walking around, weather information and so on, so multidimensional combinatorial kind of problems. And especially if you combine it with AI, it's of course, the world is ours. Yeah. So I think that's a very interesting technology to look for the coming years. And what we see now actually is that we are transitioning from the general purpose computer into this quantum computer, but there are no production ready quantum computers available right now. Yeah. What is available is technology that bridges this. For example, digital needle technology, where you can actually already build a couple of these kind of use cases with technology inspired on quantum. Yeah, and that technology is also available also for Jitsu, is one of the companies in this that's very strong in this. And I think we're already building amazing sort of use cases on top of this. And this really gives you a sort of heads up into the quantum computer space. And especially when you think about Jitsu, we also have the top one supercomputer Fugaku in the world. You can imagine that a lot of these kind of use cases that are actually used for supercomputers are also very interesting candidates now for AI and quantum computers. What it means, though, is also for all of you. Yeah, and I don't know what kind of blend we have today that is listening to me, but probably a couple of people of you will be responsible for IT. You will be giving direction to IT. You will be in operations. You will be in development. So what you see is you really need to build new skills. Yeah, because it's difficult to start with the SDGs and the sustainability and so on, translate it into an approach, translate it into models in software, then build it into a circuit and then run it on a quantum computer. Yeah. So you actually need a lot of new skills that actually are able to translate approaches to software, to circuits, and then to quantum mechanics. Yeah, because you will see different roles on all these layers. And in some interesting cases in that are, for example, the computing infrastructure that you actually use for drug discovery, right? So all the thing around corona and the vaccines, actually also the Fugagu has been used to actually figure out if, for example, drugs that is already in use for another illness can be used in the context of corona. Yeah, so these kind of things I think are very interesting us to in moving forward. But that means on one side, this is very much about business and sustainability goals, and on the other side, it's really hardcore technology, right? Circuits, because at the end, the circuit needs to run on a supercomputer. So it's not one person that will be able to translate this purpose into models and circuits, but you have different roles that can actually do this translation. And on the right, you have a completely new sort of technology with quantum gates and so on, which is a completely different way of compute power than we had before in the traditional way. So if you look at some potential use cases, you will find cases like this. Investment portfolio optimization on the short term, non-performing loans, optimal trading, credit scores, but also risk modeling and so on. And this is just a small handful of cases that we already see, but you can imagine the potential in this is enormous. Yeah? And quantum computers will not replace traditional computers, but they will actually be next to traditional systems, because sometimes one works better than another one. Yeah, the same with CPUs and the graphical processors and so on. Sometimes one is better than the other in a specific case, and that will actually also be the case for quantum. What you also see is that also quantum is becoming available as part of the hyperscaler cloud. Yeah? So if you look at the Huawei and the Tencent, Alibaba, Google, Amazon, and Azure in this case, the 6 main hyperscalers in the world, well, of course, we are much more familiar here with Google, with Amazon and Azure, and in the company context, probably most familiar with Amazon bracket or sorry, with Amazon or with Azure. Maybe some of you are already experimenting with Google, or depends a bit on your business. But these are the sort of the core in here. And what you see is they're all trying to figure out also what to do with quantum. And actually also quantum in a sort of way is available also in these hyperscalers as well. Yeah. So if you look at Amazon, for example, they have Bracket. And I think in essence, it's not a pure quantum computing in that sense right now, but they really have different technologies underneath, and you can already sort of do simulations on this as well. So in the end, this will all make up as a sort of part of your hybrid IT landscape. Not to forget supercomputers. Yeah, supercomputers in 1968, I already said. If you look at them now, they were fast then. Now they're slower than your smartphone. Yeah. So if you have a newer phone than an iPhone 7, which you probably all have, then this supercomputer is slower. That doesn't mean they don't have a role now, because if you look at supercomputers now, the number one supercomputer Fugagu in the world is actually as fast as 20 million smartphones in a single room, or 300,000 standard service, which means you can have 2 Fugagus and you can run the entire Japanese cloud. Yeah. So I think that's really where you see the future of computer power going. Okay, I'm getting a bit more closer to the end, but I really would like to tip on 2 topics here just briefly. And that's one is of them is agile, and the other one is the data part. If you look at agile, every company needs to be more agile in the way you deliver services and the way you can change your organization. And of course, agile is really coming from a software background, right? If you talk about DevOps and Scrum and so on, although agility was already in the business context a known word, you really see that the software side really introduced this also to the wider organization. And now financial, business, security is all coming together in BizSec DevFinOps, like I said before. And we also see some interesting models. For example, the Spotify model that's really known and used by some of the organizations currently also, where they try to figure out how to deal with squads and chapters and so on, how to deal with tribes, but also how to deal with cloud providers and integrators like Fujitsu. Yeah, and what role does Fujitsu actually play in all of this, right? Are we in the development team? Are we in the platform teams? Are we supporting this? How does this actually work? So what we see now is really a translation of agile working in sort of detailed models now. Yeah. So what we really see is that on the business side, these DevOps teams, they really are focused on applications, and they really are a blend of different sort of capabilities, product owners, scrum masters, developers, testers, but also solution architects, cloud solution builders, cloud specialists. And somewhere in the back, there's this person running platform operations, which is sometimes visible and sometimes not that visible, and can be a combination between the cloud provider and integrator. So what we see, and it's actually also what we see in our existing accounts currently and new accounts that we are working with, one side is really digital business. If you look at the application development, it's much more about application build and run, where also integration brokers are becoming a part of running these kind of platforms together, and then setup of platform teams that actually provide these self-service platforms, because it's not just going to Google, log in, put your credit card in and get going, right? And hybrid IT landscape is much more complex than that. And also you need like blueprinting stuff. You need to make sure things are monitored and all those kind of things. So actually that's also where the integrators come in and where they can play, I think, a very important role. But it also means in the complexity that you can get in this situation, right? Multi-Scrum, multi-cloud, multi-CI/CD pipeline. And so you have development teams, and you see a part of the SAFe model here, where you're actually working with developers and so on, and you're doing this continuous operation and continuous deployment and continuous integration. So you're already connected dev and ops, but you also have to do with multi-cloud, right? AWS and Azure. So the CI/CD pipeline that you have will tap into on one side AWS and on the other side Azure, but also your private cloud, your legacy cloud. And so also the toolkits that you're using, and you just see a sort of an example here of the tools you could have been using. Dynatrace, for example, continuous performance management, ServiceNow for governance and control, and all these others around it, which can work together in your CI/CD or your continuous operations approach. And sometimes they work well on one platform, and sometimes you have to choose some other tools in another platforms, yeah? Because maybe for Azure, you don't want to have this generic set and you want to use the DevOps specifics of Azure. And that's, I think, a very important choice you need to make, also in the tooling and how to keep this going and how to keep this working, especially when you think about setting this up as a continuous operations approach. Then my last point is about data, digital data. And I always use this picture in my digital data discussions because I think it's a bit simple. It shows this concept of data lakes where you're actually trying to connect data, where you're actually trying to create different sort of lakes, maybe one for marketing, one for financial reporting, one for customer insights, but some maybe also for IT monitoring or IT testing. And if you look at this, of course, you also need to figure out how does this actually work? How are you going to build a lake like this, a connected lake like this on a hybrid IT landscape, yeah? Especially when one part of your data is on premise and one part is in this nice Google environment where you can do the AI analysis on. Yeah? So you need to figure out how that works and also what kind of tools that you're using. But also, how do you allow your business to actually fish in these lakes, to actually catch a fish? Because if they find a fish, for example, a conclusion, can they actually take this conclusion? Or are there regulations actually that you need to deal with before they can take out this fish? Yeah? So maybe they should show where we fish. Maybe you can let them take their own tools, let them fish. But maybe if they find something, you need to have a strong process that actually checks on it before you can actually use it in your business context, because that's one of the very big challenges we see around these data lakes and AI and analytics approaches that we currently see. And that means there are also a lot of initial and interesting use cases on this, yeah? Things that we have never been able to do before. For example, what price are we paying for a specific risk if you're an insurance company, yeah? How can we reduce cost, yeah? Is a customer actually able to pay or not? Yeah. Can we make a customer interaction more efficient? A lot of things that we can maybe figure out if we have these lakes and intelligence on top of it. And then, of course, you need to be able as a business to actually execute on it and implement it. Because if you find hundreds of findings and you don't have anything in your business that can actually deal with this and make it better, of course, there's no use. Setting this up is actually an interesting challenge that all companies have nowadays. And of course, we see also on the data side a lot of data capabilities on all these platforms that are already out of the box, usable, and where you can start. And of course, when I talk about hybrid IT, it's not just about these public clouds, but of course, you can also have stuff on premise as well. Which means this is the future digital IT landscape, in my view, for all organizations. Purpose-driven organization built on enterprise agile teams that build applications. They use standard data from data cloud platforms, which are generic over the hybrid IT space, and they use the capabilities from the digital business platform. And underneath, you have this hybrid IT landscape where you also have different sort of computing power, traditional, quantum inspired, and also supercomputers. So if you would go a bit more details, then it could look like this, right? Public cloud, on-premise cloud, quantum, but also legacy and private cloud services on the right. Very quick overview in very short time. I hope you guys enjoyed it. I enjoyed it, although I didn't see you, so I'm looking forward to a physical meetup with you somewhere in time, so we can actually continue our conversation. And of course, don't hesitate if you have any questions or whatever after this session to reach out to me, and we'd love to continue the conversation with you. Thanks.